both rats, black rats, and feral cats are known as generalists. So within generalist populations, what we often see is that individuals might occupy a subset of the total population niche and specialize on a preferred prey item, even when it's relatively less abundant than other food items. So there's some theoretical as well as empirical evidence that the folks that are managing these populations have seen that they suggest that cats come into a colony and are rather naive and can learn to capitalize on this rich food source that is seabirds. Rat predation is a little bit more complicated as black rats are largely vegetarian when they're not on seabird islands, but have learned to capitalize by eating eggs or chewing on the heads of nestlings and legs, and it's a pretty gruesome story. So we want to know, are there individuals that specialize on seabirds? So this project comes from the work being done up in the Hano-Napali Natural Area Reserve in collaboration with the Kauai Endangered Seabird Recovery Project and the Hano-Napali Seabird Mitigation Project. So the samples are coming from the efforts that Alex and Kyle and Andre and their crews are putting forth to monitor and protect the Newell shearwater and Hawaiian petrel breeding colonies up on the island. So the idea here is that stable isotopes are a great tool for looking at, for characterizing diet, specifically the composition of marine nutrients into the diet compared to terrestrial. So we're focusing on understanding this variation between the marine and terrestrial proportion of their diet. And we're asking the question, are there individuals that have a seabird specialized diet? And we're calling something a specialist if its diet exceeds 50% seabird. And we go to this idea as stable isotope ecologists, we rely on the fact that we are composed of the molecules that we consume. So whatever we eat is ultimately synthesized into our tissues, and a story can be told by understanding the ratios within our tissues. And so when you take on a project with stable isotopes, you want to kind of have a good background and understanding of whether or not the isotopes can be applicable in that situation. And so often we use stable isotopes to differentiate terrestrial and marine sources of those nutrients. So you're going to see these biplots here today on a number of slides. So nitrogen will be on the y-axis and carbon will be on the x-axis. And nitrogen is often used as a trophic indicator, which is very useful, but in this situation, the difference between terrestrial and marine along this nitrogen axis is largely a product of the source of those nutrients, and similar with carbon. And so in this system, if we think about what would plot in these different areas, so marine seabirds, our Hawaiian petrels and Newell shearwaters would be in this top corner here, and the terrestrial items such as rats, forest birds, insects, and fruits would be down in that general area. So the methods that we've applied here were to work with whiskers. So whiskers are really cool to work with and really easy. All you have to do is pluck them and wash them, and then you can run them. There's no freeze drying and lipid extraction, so that's really fun, and they don't smell terrible. So we're looking at 14 individual cats here today. Plucking the whiskers, what's really cool, I've learned from some studies on rats, is that you can determine, basically whiskers grow continuously until they reach a certain point where they stop growing. And when they stop growing, they form a club. So you can kind of see how this whisker here looks different than that whisker there. So when I pluck a whisker, I can look at its base and determine if that whisker was continuously growing, and then back calculate from that date that the cat was captured by taking segments. So I took 3 to 5 5-millimeter segments from each whisker. Each 5-millimeter segment represents roughly a week. And we stopped at 5 just because sample size got below 0.2 milligrams, and we don't have good precision or accuracy on our instrumentation for running that. So 5 segments, each representing a week. We can look at diet of an individual over about a little over a month. So for the black rats, though, we just have pulled 1 whisker from an individual and got 1 sample point. Each whisker for the rats represents approximately 1 month. And so we sampled 61 rats, 25 during the off season and 36 during what we're calling the seabird season. And we use stable isotope analysis in R, the SIRE mixing models, to estimate the proportion of seabird or marine nutrients in diet. So here is a piece of Dimitri Pollock's artwork that I stole from some museum. Just kidding. Does anyone get that joke? Looks like threw like splatter paint on a graph. No. Okay. So we'll walk you through this anyways. So here we have the Julian date, and we've kind of overlay the Newell shearwater and Hawaiian petrel breeding phenology on the bottom. And we're able to look across time. These open squares represent rats during the off-season, closed squares rats during the on-season, and we see a slight shift to higher nitrogen values during that time period. And then each of these different colored lines represents an individual cat, so each point represents a segment of its whisker. And we see a lot of variation here, so some of these are stable. That means its diet's fairly stable over that time period. We have a couple here that have this big jump, suggesting a shift in their diet. Again, this dotted line represents about where a seabird would be sitting isotopically. And it kind of stands out, this guy here. I don't know what's going on with that one being prior to the seabird breeding season and being so high, suggestive of consumption of seabirds. Could be misinterpretation of the clubbing of that whisker or a bird that was consuming a different species breeding during that time period, but just pointing that out as an interesting case there. So carbon, same idea. We see a slight increase in the rats between the 2 time periods, with a couple of individuals showing these really elevated carbon values during the seabird season. So that's just kind of exploring the data over time. And so to develop this mixing model, we utilized isotope values from Hawaiian petrel and Newell shearwater mussel to set a marine source, and then this green is our black rats. And then we had 3 mice here. So the mice are sitting in between the seabirds and the black rats here. And that makes sense in that mice are more insectivorous than rats tend to be. So it's kind of cool to see them there. And so now we can lay the cats over top of this. So these are 90% density ellipses. And the way we interpret this is, the majority of the isotopic niche of the cats is lying in this terrestrial zone, so consuming a lot of terrestrial food items. But we see that it does extend up towards seabirds, suggesting, as we know, consumption of seabirds. Now, if we break those down and display it as individuals, so each of these reddish-pink ellipses represents the isotopic niche of an individual over its sample period, we see that there's a lot of individuals who seem to be terrestrially specialized on their diet, not consuming much outside of the terrestrial zone. But then we have a couple of individuals who have broad, more generalized, cover more a greater trophic niche width, and some individuals who are smaller but also higher here. So we use, basically, this is kind of a way to visualize what we're going to do with our mixing model, and here's kind of the results of a mixing model for our cats. So 3 out of 14 of our cats were considered specialists, so again, consuming greater than 50% seabird in their diet. The average is only 28, and the range is from about 7 to 80%. So here we have these 4 individuals, with the highest one being suggestive of eating 80% of its diet composed of marine nutrients. And again, we make the assumption that proportion of marine nutrients is equal to seabirds. So I forgot to mention this point earlier. we rely on the idea that in these upland habitats where these birds are breeding, the shearwaters and the petrels are the only source of marine nutrients to that system. For the black rats, we do see a lot of variation. So this is just for on-season black rats because it doesn't make sense for rats to be eating seabirds during the non-breeding season. And we do see one individual who's pretty high. I think it's at about 35 or 40% there, a couple more above 25%, and generally these are all pretty low. The mixing model can't necessarily say they are eating 0 marine nutrients, so some of these low values might actually be 0%, but we can't really say that exactly. But proportion of the diet is not really all that applicable in a lot of ways. What we want to kind of quantify is, so how many seabirds does that mean? How many seabirds did an individual cat eat? So we can use some assumptions to make some estimates. So your veterinarian will say that a cat needs 2 grams of protein per day per pound of cat. So if you're on average weight of 5.5 pound cat, which that was the average weight of the cats in my analysis, that would mean they need 11 grams of protein per day. And if we estimate what they might be getting from a seabird, I put it at, the blue represents 60 grams from a seabird. That would mean that they're getting a ton of really efficiently consuming that seabird versus 30 grams where they're just getting not all of the protein available, or maybe it's a nestling. And based on that average cat, if you're eating 60% seabird, you'd be eating 50 seabirds over a 225-day period, representative of when they're exposed to shearwaters on the island. So for the cats that we captured and analyzed, we see that, again, only a few seabirds being consumed by the lower proportion of that population. But then we have these individuals up here that would estimate over 25, almost 35 seabirds during that period. So recommendations for management, clearly eradication should be the goal, but on an island like Kauai where you have limitations to achieve that, you need to specialize your trapping methods, as Kyle presented so well yesterday, to target these individuals that are eating seabirds. Future directions we'd like to go is to better resolve our mixing models to differentiate that terrestrial proportion of the diet, and develop agent-based models to further explore the consequences of this individual specialization. And so I just want to throw this up here and show you guys, like, this is our lab. We have a window that looks out over Hano and Napali. At least I pretend that way. But it's just really great to be here and be surrounded by everybody who works here. Did I already thank Craig Strong? Okay, so Craig Strong donated his airline miles that were gifted to me as a travel award. So he says hello, and I want to thank him for that. But yeah, so we get I'm getting a lot of excitement and encouragement by coming to this island and seeing how hard everybody works on this seabird conservation. So thank you for bringing us here, and I'll talk about that another day. So thank you.